Hey guys, the aim of this video is to show you how to convert a UDL into a point load. So on our first example, we have a beam with a rectangular UDL of 20 kilonewtons per meter. And as you can see, the units for this loading is kilonewtons per meter. For a point load, we want to convert it to a single force, so we want this to be kilonewtons. So how we achieve this is we multiply it by the length of the beam. So if we have 20 kilonewtons per meter times 5 meters, you can see the units of meters cancel out and we're left with 100 kilonewtons. So as you can see, to get the point load of a UDL is simply to find the area of this UDL. So it would be, the height would be 20 and the length would be 5. However, just knowing the point load is not enough. We need to know where it's located on the beam. So for a rectangular UDL is simply the halfway point between the rectangle ends. So in this case it would be 2.5 meters. So roughly the point load would be here. And we represent this point load as higher than the 20 kilonewtons, so it will be 100. And this would be 2.5 meters from the edge of the beam. So one way of thinking about it is that this 100 kilonewtons at 2.5 meters imposes the same effect onto the beam as this 20 kilonewton load over 5 meters. They both do the same thing, but in this case, now that we've converted to a point load, it's much more easier to find the support reactions. So over here we have one support reaction, and over here we have one support reaction. And we know that it's just 100 divided by 2, so 50 kilonewtons and 50 kilonewtons. Later on, this will be even more useful when you decide to cut beams and find the bending moment diagram and shear force diagram. Okay, so example 2, let's look at the triangular UDL. So same idea, to find the equivalent point load, you need to convert this area of this triangle into a force. So the area of a triangle is simply half times base, which is 5, times 40. So half of 5 times 40 is 200, divided by 2 is 100. For a triangular UDL, the point load centroid is actually slightly different to the rectangular one. As you can see, the UDL is more heavy-sided on one side, and it actually works out that the centroid is actually 1/3 from the heavy side. So 1/3 from the heavy side, 100 kilonewtons. And the centroid for a triangular UDL is 1/3 from the heavy side, so it will be 1/3 times 5, which equals to 513 meters. If you wanted to work out the centroid from the smaller side, it would simply be 2/3 times 5, which equals to 10/3. This is from the right hand side. So now that we've found this point load, we can actually find the support reactions much easier. So let's call this support reaction A and this one B. Now this time we have to use moments because it's not so evident. So let's call the moment at support A counterclockwise as positive. We have the sum of moments equals 0 for counterclockwise positive. So we have minus 100 times 513 for our first moment, plus B times 5, and that would equal to 0. If you work out B, it equals to 33.33 kilonewtons. And now we can just use the sum of forces in the y direction equals to 0, where positive is up. So we have 33.33 plus the reaction at A minus 100, or equals to 100. So if you work out the reaction for A, it would be 66.67 kilonewtons. And this is how you convert UDLs to point loads.